Good evening, everyone. Let us start the session. Today's agenda is more focused on clustering methods, right? So how do we implement clustering? When it comes to real world clustering and when what we do in simple projects and all, it is a bit different from what we really actually do. So our focus will be more on how clustering can be done at the industry level and how recommendation systems and all will be used. So that focus we will do today, right? So let us without any further delay, let us start the session. Let me share the BPT. So today it will be more focused on project based. Okay. So let me just give a brief introduction about what is clustering and why what is the need for doing clustering and what is the use of using a method called clustering. Okay. So let me share my screen. Okay. So first, let us see what is clustering. Right. I think you can see my screen. My voice is also clear, I guess. Yeah. Fine. So let us see what is exactly clustering. It's a technique which is used to group things. Okay. Or I can say group objects into clusters. So basically what is exactly clustering is basically grouping them into homogeneous groups. That is what basically the textbook definition of what is clustering basically is. So when it comes to clustering methods, we have many methods which are which are basically used. Like the two main methods which we highly use is the k-means clustering as well as the hierarchical clustering. Right. So these are the two popular methods, I would say. Okay. So there are many more clustering methods also, like the DB scan, fuzzy c-means clustering, and so on. So there are a lot of other methods when it comes to the clustering also. Right. So let us focus more on the very popular methods, right, and how to implement into a real world project and how to do the customer recommendation systems. Okay, so that is what the main agenda is basically about. Okay, so once we have done with the clustering part, then we'll cover the SVM. Okay, maybe in tomorrow's session. So now, so the first one where I'm, which I'm speaking about is the k-means clustering part. So this k-means clustering is basically a cluster, or a k in k-means basically tells you about the number of clusters. So number of optimum clusters which can be formed in the data set. So k-means clustering uses the formulas like the Euclidean distance and so on. So let us dive a little more deep, as I told you the one more clustering technique, which is the hierarchical clustering as well, right? So this is basically you know something called which is predefined to build for k-means. Particularly if you talk, if you ask me about what is, how do we implement the k-means, we have some method called as the elbow method. Okay, that we will implement in the project, and we will see when how to implement the elbow method, and how to identify the optimum clusters and all. So in coming to the hierarchical part is nothing but a tree-like structure or a tree-like representation, which is actually represented where you can see the clustering part. So let us try and understand with a very simple example, okay? Because how much of concepts theoretical, it's more important to understand with an example, right? So let us start implementing or start understanding first of all that what exactly is this clustering about it. So a very small example I've taken for you to understand first. So a bank wants to give credit card offers to its customers, right? So this one you see on a on every bank, right? This is not something which happens only for a particular bank or something like that. So it is actually happens, or for every bank this will go through, whether it is private banks or government banks, any kind of bank. So now, if they want to give or provide credit cards to the customer, what is the focus should be, right? So on what basis they have to focus first? Now, currently, they look at the details of each customer and based on this information, decide which offer to be given to the which customer. So I think this part, even we know that, banks do some analysis and understand that, which customer or which kind of customer requires which kind of credit card, right? So now, when we are saying which group or which kind of customers, right, we are using the word which kind, right? So which kind is what the grouping is all about. That is in where we talk about the most important word, which is the clustering. So that means if you group a particular customers, right, and if you want to give a certain credit card to the customers, right, why you're grouping? Because you feel there are some similar characteristics among those people who are, who will be my potential customers who can take a credit card. So that means you are finding something in common, that these kind of people are uh, even our project, what we are going to do today is on that is about that only, online retail. So how to group the customers. So you're saying, when you say these kind of people we want to give credit cards, you're saying you have to group those people, right? You have to identify first of all that which kind of people has to be given which kind of credit card, right? So for this grouping part, we use the clustering technique. That is how the you can relate it with a real world example. So now the bank and potential have millions of customers, right? So does it make sense to look at the details of each customer separately and then make a decision? Certainly not, right? You cannot look at each customer and you cannot give the, or you cannot segregate customers on that basis. It is really difficult. So it is a manual process and it will take a huge amount of time. So, you can do it, but it is usually takes a lot of time. So next is, so what can the bank do, right? Now, what one option, a very small option we have provided them as, you can segment the customers into three groups. One is your high level income, one is your average level, one is your low income, right? So this is a small example to identify the clusters, okay, or to identify the people whom we can offer the credit cards. So now, right? So now bank can offer three categories. Now then, if you can make into these three categories, now you can identify, or now you can say formally, right? Or you can strategize that here I need to make only three strategies because there are only three groups of customers, right? So for low income people, what should I do? What should I do? So these, okay. So it's not that simple what I'm speaking right now. So things are a little tougher when you start analyzing a data set. Okay. So that we will try to understand even more in detail. Okay, right. Now, the groups I have shown about are clusters, and the process of creating is basically known as the clustering techniques, right? So now, this is basically dividing into the, it is basically we are dividing into different groups. Okay, so here a very small example I mentioned of a mart. Okay, so sales in a particular mart. So you can see the outlet size, outlet location, right? Outlet type and the item at the outlet sales. Okay, and now let us understand also what you can predict. Okay, so for example, here I've taken one example to predict the sales. Okay, so like this, you have different kinds of supermarkets. One more example here, you can see that whether the person will get the loan or not. Okay, so on his marital status, loan application, that application's income, his loan, right? So his loan amount and loan status. Okay. So in the above thing, which is the sales prediction, you can see that item outlet sales based on the outlet size, right? So that only we have to identify whether which things have to be clustered in which kind of grouping so that the sales will be more. Okay, right. So such problems we can, for example, I just, very important thing is to understand why clustering comes under unsupervised. This is a very important point I wanted to discuss before going into a project part. Okay, so why clustering is coming into an unsupervised but not a supervised learning, right? So we have seen decision trees, linear regression, logistic regression, random forest. All these are actually coming into supervised learning, right? Now, here, we cannot put that same clustering technique, right, into unsupervised learning because of the sole reason that all these algorithms, what we are trying to implement, all these basically have, when you analyze a data set, right, they basically have a target variable, right? So this target variable is what segregates the unsupervised and the supervised learning. For example, if you have a certain target variable in a data set which you can predict, so if that is there in the data, then the data set or the algorithms what you can apply is basically a, right? What exactly it is? It is basically a supervised learning. But when it comes to unsupervised learning, for example, you want to segregate the customers or you want to group them or you want to cluster them, right? On their behavior, on their earning, on their, might be how, they purchase things. So here you do not have a particular target to predict, right? You are just grouping them, right? So that, or you are giving some recommendation based on the kind of grouping, the nature of the things and all. So that is the reason here we do not have a particular target where we want to, uh, predict that particular target, right? By using predictive analytics part. But we don't have this part when it comes to the clustering, right? So that is why it is basically called as an unsupervised learning, but not a supervised learning. Okay, so let me, yeah, so k-means we have discussed, but one thing I just wanted to talk about in the k-means part, right? So first of all, the most important part, it's a very popular unsupervised algorithm, right? So this is, some theoretical part just wanted to tell you, right? This is basically used for, defining the clusters, right? So there is a method, in k-means clustering, which is called as the centroid method. We use the elbow method, right? And we also use the distance between the objects, or you can say the distance between the data points, right? So, so that is how we are going to classify, or that is how we are going to group them into clusters. Okay, so this is basically an overview of how the clustering actually works. Okay, so randomly we start with the data point and we try to calculate the clusters, or it starts, I can say, the algorithm only starts by randomly selecting a data point, and then from there it will try to calculate it will try to initiate the clustering centroids. Okay. From there, it will try to calculate the distance between the points by using it can use multiple methods, for example, like the Euclidean method, right? Or it uses the Manhattan method, right? And like that, we have different kinds of formulas which can calculate the distance between the two data points. And what happens is, if when it starts to find the distance between the data points and the shortest distance are started to group together, and for those points, a centroid will be calculated. So based on that centroid, right, the other data points will be started to, or will be started to, put into one cluster or a group. It will start grouping until and unless, the data points all are, clustered in a one particular, group. Okay, where the, centroid doesn't change much. Okay, so this one is repeated until this feat has been achieved, and that is how we are going to conclude that it is the clustering part is actually or the clusters are, we have achieved the optimum clusters. So objective of k-means is basically to group them, right? The very important thing is that is where the elbow method comes into the picture for this data points. Okay, so the implementation of elbow method is like a huge thing when it comes to the k-means clustering part. Okay, so here what we are trying to find is we see the main aim of applying this k-means clustering or any clustering algorithm is the clusters should be homogeneous, right? The elements in the cluster should be homogeneous. That means the the behavior of the data points. That is why we were speaking about high level income, middle income people and low income people. So the mentality mostly of the low income people will be similar, and high income people will be similar, and average income will be similar, or the middle income. So this is how the behavior actually stands. So to achieve this part, where that is why we say the data points inside a cluster should be homogeneous. That means the behavior should be very similar, and the behavior between the clusters is should be heterogeneous. That means when you see the high income group and the low income group, right? The behavior should be exactly heterogeneous. It should not be a homogeneous behavior. So if your data points inside a particular cluster is homogeneous and between the clusters it is heterogeneous, that means we can say for sure that the optimum clusters or optimum segregation of groups has been actually achieved. Okay, so this is basically the objective which I've been saying as well. So for this we are going to use some standard methods of formulas to achieve this, to calculate the distances. In that, one of the standard distance measure is the Euclidean distance. Okay, so Euclidean distance is a formula which is which we use it in school math, right? So distance x1 y1 x2 y2, right? So x square root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is the formula which actually the k-means clustering actually uses to calculate the distance between the data points, right? To calculate sort them into one cluster. Okay, fine. So let us see one more example. Then we'll directly jump into the project part. Okay, yeah. So it's almost 25 minutes into the session. So because I've taken a very big project for you to understand that how actually segregation can happen. So I think Ma'am Hesh would have shared the data set. Can just link. Uh, Maybe you can download the link. Let me share or let's just wait. Share. I'll take it from. Yeah. So share the link. I think you should be able to download. So I've shared the link. You can download the data set. Okay. So let us see one example. Okay. So we'll take the bank example, right? There we have actually divided the customers into three segments based upon their income. So let us say we want to use the income and debt to make the segmentation now. Now, before we have used only one parameter, which is the income parameter. And let us see how much of debts they got also, right? So it is very important to do that as well. Right? Why it is important? For example, a person who is having a lot of debts, there's a high chance that he might not take credit cards. Okay, or there is a chance that he might take credit card to clear those debts, okay, to use it also, so that we can understand that how the customer's behavior is also. So we can plot that data on a graph, right? So here we are going to, see the correlation between the income and the debt as well. So now you can see a graph like this. Okay, let us say we have plotted and we have got a graph like this. Okay, now after plotting the graph on the income and debt, you can see here on the x-axis, basically we have put the income of the customer, right? On the y-axis, we have mentioned about the amount of debt he has. So here you can clearly visualize that the data is being segregated into four clusters or segmented into four clusters, right? You can see four clusters. See here, those four have been circled. Okay. So now, based on this segregation, right? Now, what can the bank do? The bank actually can further use these clusters to make even more strategies and offer discounts to the customers. So now, as I already told you that, the properties between the cluster or the nature of data points within the cluster should be very similar. Okay. So, see here one more example. If the bank gives them the same offer, they might not like it, and their interest in the bank might reduce, which is not ideal again. So that is why it is very important to target that particular, even though it is within the same cluster, targeting the customer on the right basis is very important. So that is what each business will actually strategize when they try to implement. That is why clustering plays a very important role when identifying the right kind of customers to sell your product. Okay. Yeah. So this is again one more property which you can identify, right? Here you can see two cases, okay, where the customers are identified. Okay, so whether first case is of identification is good or the second case is of identification is good, it is based on the type of strategies what we are trying to do on the business problem. So that is why we'll take up a business problem and try to understand on that basis so that it will be easy to understand how the clustering works. So in the case one, if you see the customers in the red and blue colors, right, are quite similar to each other. The top 4 points in the red cluster share similar properties to those in the blue cluster. So they have high incomes and high debts also. So here we have clustered them separately. Whereas if you look in the case 2, points in the red cluster completely differ from the customers in the blue cluster. All the customers in the red cluster have high income and high debt. Correct, no? Meanwhile, the customers in the blue cluster have high income and low debt value. Clearly, we have a better clustering in customers in this case. Correct, no? So this is how we try to strategize. Now, let us see a few real-world case studies, and we'll directly quickly jump into the project. So some of the real life use case studies are, customer segmentation, right? That is what we are going to do as a project. It's a very, very important strategy, particularly in a retail business. Okay, so and retail business projects are, very, you will get very high retail business projects when it comes to a real-time analysis, because that is what every people they want to strategize which kinds of groups they want to sell the certain products, to whom they want to offer discounts, right? To whom to how whom to target, right? Where to campaign, all these things. So definitely, the retail, that is why I really like this customer segmentation, because the retail business is a business where you get more amount of projects on as well, right? So next thing is the image segmentation. So for segmenting the images based on the their identification of different kinds of diseases, for example, like the MRI scans and the CT scans. So you can use in computer vision as well image segmentation for doing the clustering. So document classification also we can use. That means aggregating, similar kind of documents, right, or articles, right, in the NLP, which is the natural language processing. So next is the fraud detection. So identifying the frauds, right, based on the spendings of the customers. So social network analysis. So it is basically whether it might be Facebook, Twitter, or Instagram, or any kind of social networking. So identifying the communities, identifying the behaviors, right? Suggestions, recommendation systems. They all use the clustering pattern where it suggests your kinds of your networks, right? Which helps you in connecting to people. Next is the recommendation system. So recommendations, you can use it whether it might be a streaming services or it might be any examples like Netflix, Amazon Prime, and so on. Or you can also imagine where you can use the recommendation systems when it comes to the right. Particularly, maybe you can also think recommendation systems can be used in e-commerce websites as well, right? So next is the anomaly detection, right, in the IoT devices, right? And then the biological data analysis, right? So in classifying the genes, similar kind of genes, we are going to use it. So that is what I was giving you indication also, that machine learning is highly used. AI techniques are highly used in the medical field as well. So next is urban planning. So identifying the things for using it in the city, where identifying traffic patterns, population density hotspots, where the areas need the infrastructure development and so on. So it can be also used for urban planning as well. So online retail analysis. So this is what how to target the customers based on the e-commerce and all those things that we are going to apply. So let me share the project. Okay, let me start. Sure, Purva. I just think on that. Maybe I'll something which is not done before. I should just have a thought. Um, I'll just give me a day. I'll just check. Maybe maybe I have some idea in my mind, but somebody would have done also, or somebody would have not have done. So I'm not sure exactly. I'll just need to. Yeah, no problem. Even it is a good thought for us also to implement a new thing which is not there before. So based on the knowledge what we have, we can uh, do a new thing. So maybe we can do that. So I'll just keep this in mind. Yeah, I'll just keep this in mind. Maybe I'll, because I have to, even though I have a thought, I should search also. Whether I search in, whether, I just Google search or I search in anything, I should search that whether it is existing or not first. So then only I can tell you it's not existing. So let me give it a try and let me check. Okay, fine. So let me yeah. So let me any questions if you have till what we have discussed, you can just ask. Okay. Mm, I'll go to the. I hope you have downloaded the data set. Okay. Just let me share the data set first. Where I have it? Online retail. Okay. So let me share the data set first. Let me discuss that. So this is the data set what I have given you. Okay, it has got huge amount of data. Okay, so if you see, there is around 5.4 lakh. Yeah, so 5.4 lakh of data is there. So it's a huge data actually. Okay, so right. So what exactly is this data set, and and what we are going to do with this data set? Okay. And what is the analysis that can be done using this data set. Okay, so that we'll try and understand first. What is this data set first? Okay, so now if you see carefully in the data set part, right, there are things such as invoice number, right? Then we have the stock code, correct? And then we have the description part, and we have the quantity and invoice date, unit price, customer ID, and the country. Okay, so this is what we have, okay, as a data, right? Now, the first number is the invoice number. So invoice number is a unique identifier. Okay, so it is a unique, you know, it's a unique identifier or a for a particular product. Okay, so here in this data set, okay, there are actually just wanted to show you something. There is also a number which starts with C. Okay, so which starts with C. So here you can see an invoice number. This number is different. See this also here, right? Compared to the other, if you just scroll down, maybe you have like this. So if they have mentioned number like this 536390, it's basically an invoice number. And if you see a number like this where you have some C, it is basically a cancelled invoice. Okay, so that is why they have represented with C. That means it is cancelled. Okay, something which is not represented, first letter as C, it is a not a cancelled. It is a processed invoice, and something which is with C is basically a cancelled invoice. Okay, so that is how data is actually segregated, or that is how the data is in the invoice column. So next is the stock code. Okay, so here you can see a code which is again given, which is a unique, I can say it's a unique code for each product. Okay, for each product we have a unique code. So if the product is, for each product, I would say, right? For example, so here you can see alarm clock. This is 22728. For the same alarm clock, but it is red color, we have 22728. So like that, for each product, we have a unique stock code. Okay. So next is the description. So description is nothing but which kind of product it is. Okay. So what kind of product the person is buying. Okay. Next is the quantity. So I think I need not explain much. So how much of quantity they would have purchased, right? So let us see. Next is the invoice date. So invoice date has the there are two things in the invoice date. One is the date of the transaction and time of the transaction. Okay. So both are actually mentioned in the data set. Okay. So next, after that, next thing is the unit price. Okay. So this is a UK data set. So the price is basically in the pound. Okay. So the data set, each product's price is mentioned as a pound. Okay. I can say UK pound, which is sterling pound also we can say. Okay. So the first product price is 2.55 pounds. Then it is 3.39 pounds and 2.75 pounds and so on. Then next is the customer ID, which is the which person has which person has bought this product. For example, I think you can see here first 3, 4, 5, 6, 7, 8, 9. So first 9 items are bought by one person only because the customer ID is same. So this customer ID will be unique. For example, if I'm ordering 9 items, right? So maybe these 9 items I would have ordered. So it comes under my customer ID, right? So here this customer 17850 has ordered this. And the next thing is the country of that particular person, whether he is from UK, France. Okay, it's a UK based company, but same like for example Amazon. Amazon is a US based company, but we are using in India, right? So the same way here it's a UK based company, but there are people from different locations as well, like the France. Maybe if I scroll down even more, so I saw Belgium, UK, I can see Switzerland also I saw. So France, UK, yeah, maybe different countries. I can see the people who bought this product. Okay. Now let us segregate the customers and let us try and understand what can be done, right, by clustering them, and how do we recommend giving the recommendation systems. So let me share my project. Okay. So let me close that. We check if you have any questions. Just ask me if you have anything, any question regarding anything. So we'll just couple of minutes and I'll see if you don't have any questions. I'll go with the project. Right. I don't think any questions. Okay, fine. So let me share the project. Okay. So let us start discussing the project part. Okay. So this is a very lengthy project. Okay, I'll try to finish it off in today's session itself. Okay. So let us start. Okay. So the project is more focused on the data set what I've shared with you. Okay. And this project actually focuses on doing the customer segmentation and giving the recommendations. Now, let us see the problem statement. Okay. So in this project, we delve deep into the thriving sector on the online retail, right? By analyzing a transactional data set from a UK-based retailer. Okay. So this is basically a transactions done between 2010 and 2011. So now what is our primary focus is to amplify the efficiency of the marketing strategies, right? And we want to boost the sales through customer segmentation. So we also aim to transform the transactional data into a customer-centric data set by creating new features that will facilitate the segmentation of the customers into distinct groups using the k-means clustering algorithm. So this segmentation basically allows us to understand the distinct profiles and preferences of different customer groups. Then by building upon, we also tend to develop a recommendation systems, not just about grouping them into clusters, also about giving the recommendations that will suggest top selling products to the customers within each segment who haven't purchased those items yet. So ultimately enhancing the market efficacy and fostering the to increase the sales or increase the sales. So based on the highest sold products, we are trying to understand that which products are sold much or sold more, and those who have not bought those products, we try to sell or we try to recommend those products to those people. Okay. So now here the most important thing what we are going to do is we are going to perform this six things. One is data cleaning and transformation. That is the first step. Then we will do the feature engineering part, which is the second step. Then we apply the data processing part. Okay. So next is the customer segmentation using the k-means clustering. And then we are going with the clustering analysis and evaluation. Then we apply the recommendation systems. So each step has its own, process or a part to play when it comes to the focus on a particular project. So here the first part, which is the data cleaning part. So we try to eliminate any duplicates, missing values, outliers, right? And then feature engineering is basically focuses on the customer, right? So what is the foundations or focus which you can show to segment the customers. So that is the first part which we are going to do when it comes to the feature engineering. So next is the data pre-processing. So in the data pre-processing part, we are going to use the dimensionality reduction techniques and the feature scaling to reduce the dimension of the data and to scale the data as well. So we have seen feature scaling or normalizing the data in the previous algorithms also. So customer segmentation using the k-means. So we are going to next apply the k-means clustering and how to segregate the customers, right? How to target the customers or how to segregate on what basis. That is what we are going to see by giving or using the k-means clustering. So next is cluster analysis and evaluation. So analyze and profile each cluster to develop marketing strategies and access the quality of the clusters formed. So it's not just about the clustering. It's also about understanding that what is the quality of the cluster that is formed as well, right? So it is like a evaluation metrics as well. So next is the recommendation systems. So implementing a system to recommend, right, best selling products to customers within the same so those who have not purchased that particular product in that particular cluster, a lot of people have bought and some people didn't bought those products. So we can aim that these kind of people buy a certain kind of product. So we can focus that, okay, so this is a similar type of a group, but this person has not bought this product and he has interest on this certain kind of products. So, but he has not bought this particular product. So we can start selling this kind of product to that particular person, right? That is what that kind of target we need, which kind of customers we have to target to sell, which kind of product, right? So that is what we are going to do in this project as a recommendation system as well at the ending part. So it's a huge project. Let us discuss a step-by-step feature and try and understand how things work in the real-time environment. Okay, so let us start with by implementing the necessary libraries part. Okay, so actually this project, please do not, that's why I didn't share the IPYNB file as well. So after this session, I will share. Okay, so just I feel just listen to what exactly I'm telling and what is happening in the project, how the implementation part is there, and how things are implemented in this project to make customer segmentation, right, by using clustering as well as the recommendation systems. So this is what exactly you know what we are going to do in this particular project. Okay, now right, in this first part, which is the in this first part is the necessary libraries. Okay, if you see carefully, there is, just give me a minute. So first part basically focuses the first part basically focuses on the libraries. Okay, that is the the first thing what we do, right? I think you already also know that, right? So first importing the necessary libraries part. Okay, now you can see that there are a lot of libraries been imported into the Jupyter notebook or the Python environment. Now let us see some of the things what are imported, right? So this is basically the first part is basically for the warnings, right? So that we have implemented in the previous algorithms as well. And then we have something called as NumPy and Pandas, right? So NumPy, Pandas, I think you're also aware of the Matplotlib and Seaborn as well, correct? So that is basically you're aware of. Okay. And Plotly for graphical objects is also for visualizations. And then you have seen something called as a plotlib.colors, right? So that is basically used for color maps and color schemes, I would say. So next is the Skype part, right? So Skype is basically used. Skype is nothing but a scientific Python. Okay, so mostly statistical concepts will be there in Skype. So you have something called as a Skype.stats.lingris, right? Yeah. So in this, what exactly we are actually doing is we are importing the linear regression and the statistical analysis. So then we have the SK module, which is the scikit-learn. So in that we are using the concept called isolation forest. So isolation forest is basically used for anomaly detection. Okay, that means very anomalies are basically an exceptional outliers, I would say. Okay, so something which is like out of the blue, which is at all not supposed to be belonging. So outliers are somewhat sometimes very similar to the data set or the data, right? A little bit out of the norm. But if you see, if I say the word anomalies, right? Anomalies are something which is happens out of the blue, like they are completely out of what it is supposed to be. So that is basically an anomaly. So this is one of the methods is the isolation forest. Okay, so isolation forest is one of the methods which is used to detect the anomalies part. So that isolation forest is basically in the ensemble techniques in the scalar. So then we have the standard scalar, right? And we are also applying the PCA part as well. So principal component analysis also we are going to apply. And the very important thing which you would have seen newly is the yellow brick. Yeah. So yellow brick is a kind of module actually. It's not a library, it's a module where it is basically used to use a different kind of evaluation technique, right? So it is an evaluation technique, and here this yellow brick is basically to evaluate this Silhouette visualization and the elbow method, because the because when you say elbow method and Silhouette, uh, we usually call it as Silhouette score. And if you have to visualize this elbow method, for example, if you have to use the elbow method, okay, you don't need a yellow brick actually. But if you want to evaluate your elbow method and the Silhouette score or the Silhouette by a visualization technique and the metrics, if you want to use a metric to evaluate it, then we have to use a module called as a yellow brick. Okay, so that is where we can evaluate it. So now the next thing is for tabulating. So tabulating is basically for creating into a table format. Okay. Next is basically inline. So this collections import is basically for counting the occurrences of elements. Okay, and inline is for plotting the graph into the fitting inside the Jupyter notebook. This is very important inline, because what happens is when you're analyzing huge amounts of data, it is very important for us to mention that fit the graph inside our Jupyter environment. So that is very important when it comes to plotting the graphs. So next part is where we use the plotly. Okay, so specifically I've used this plotly because this is basically used to if you are having any JavaScript or you are having any CSS files, you want to read into the environment of the Jupyter notebook, you can use the function which is the plotly, right? So plotly dot offline import init notebook underscore mode. So this is a function which is basically a standard function which is used to import any CSS and any files from the web. Okay. So next thing is the Seaborn part. So for the Seaborn part, we have to here I've mentioned a couple of things, which is to set the different styles, backgrounds, right? So I just want to give a particular style and a particular grid for the backgrounds. So I'm giving this particular thing for the Seaborn library. Okay. So that is in where sorry, that is in where I'm using this setting of the style particularly when it comes to a Seaborn library. Okay, so this one, if you have any CSS file, JavaScript files you want to import, you can use it, or if you don't want, you need not use anything. Okay, so now coming to the next part, this is basically right. So this is basically reading a file, so which is actually I've shared it with you as well, right? So this is the data set, online retail data set, right? And I've given the address of my my laptop where I can read the data set. Okay. So now, if you see this, if you start giving, right? Okay. Now, let us go to the description part, which I already have told you, right? So all the things what I mentioned are here. Okay. So let us go to the after reading the data set. Let us go to sorry. Let us have we have done with the reading of the data. Let us start with the preliminary analysis. Okay. So in the first part, we are just printing the head of the data. So head indicates the first 5 observations. But here, since we have given 10, okay, So if you just don't give like this, for example, if you just mention like this, it will print the first 5 observations in the data set. So if you mention here 10, it will print the first 10 observations. If you mention 50, it will print the first 50. So if you mention any number, it is going to print that particular number of observations. But if you don't mention anything, it is going to defaultly print as first 5 observations. So once that is done, let us go to the next part, which is the info. Okay, so info basically tells you about the null count, right? So if any null values are there in the data set, it will tell you the null count in the data. And it will actually also show you the data type, whether it is an object or an integer. Okay, so it is going to show you that particular data type also, and it is going to show any null values are there. Now here, if you see, you can see that the observations are different in different columns. So 5,41,909, I think is the number, and you can only see that in the invoice number, stock code, and quantity, invoice, date, unit price, and country. So in only 6 out of 8, you can see that you have the entire data. There are two columns. One is the description, and one is the customer ID. So in these two columns, we don't have the final number which is supposed to be there. That means they are missing values, or missing, the data is missing in that particular right column. Now, let us go forward. So here, as I mentioned, it is basically 5,41,909. Okay, so it is around 5.4 lakh data which is there. Okay, and as I told you, there is a lot of entries which are missing, particularly in the field of description is somewhat better, but lot of data is missing inside the customer ID. If you see, right? So that is what this preliminary inference is basically about. So the inference here is about the kind of right. It is basically about the kind of data type that particular thing is, what it contains, right, and what is the information which is provided in that particular cell. Okay, so that is what the thing is. Okay. Okay, so now I hope you have just gone through that. Let me check in the meanwhile. I have any questions. So just go through this. Um, let me just take a 5 minute quick break. I'll just come back. I'm keeping my screen like this. Just can you go through this? Sorry, just let me continue. Okay. So this is about the description part of the the initial analysis, or I can say not let us not say analysis also. Let us use the word initial overview or initial impressions that what our data set actually is trying to tell us and what is available in the data set. Okay, so there is what the main overview of or the brief overview of the data set. What is the initial impressions of our data? So now let us go to the next part. Let me do little more analysis now. Okay, so let us start with very basic analysis like the summary statistics. Okay, so here you can see we are doing the summary statistics for the numerical variables. Okay, and it has taken three columns, which are the numerical variables. In this, quantity, unit price, and customer ID. In this again, one particular column is not useful even though it has calculated statistical summary. So that is basically customer ID, right? So customer ID, what is the use of calculating? Even though it is a numerical value, we cannot calculate what is the use of calculating mean standard deviation, right? So for quantity, we can calculate, right? So what is the minimum quantity? What is the maximum quantity? Right? What is the mean? What is the standard deviation? Right? And that we can calculate. Now, let us do the analysis for the categorical variable. So in here, if you see, the first part is for the numerical. And let us do it for the categorical as well. So invoice number, right? Stock code. Okay. So then description, invoice date, and country. Okay. So for this, we are going to do the statistical summary. Now, let us see what has happened in this data set. Okay. If you see carefully in the summary part, the minimum value here is minus, and the maximum value is the same number, which is plus. Okay. So what is this exactly about? So in the quantity, you can see that the transaction average is basically 9.55. So you can see that. So the quantity is basically around approximately 10 is the mean value. So that means averagely a person has ordered around 9 to 10 products. Okay, I would say 9 to 10 because it's basically 9.5, not 9.8 or 9.9. So it's basically around 9 to 10 products a person is actually ordering, right? A person is actually ordering that many quantity, sorry, not products, quantity of products. Now, the next thing is to understand here is the quantity has a wide range, which is a minimum value of this value we have seen, which is a negative value here. And for a maximum value, you are seeing this. So the negative values indicate returned or cancelled orders, right? Which needs to be handled approximately. Sorry, appropriately. Sorry, sorry, my bad. So because it is very important for us to understand that there are certain products which are cancelled also, right? Because when we see an online transactional data, there will be products which are returned, there will be products which are cancelled. That happens when you do an online shopping, that happens, right? And here, if you can see that the standard deviation is quite very large. So let us go back again and see here. See, 218 is the standard deviation. That means there is something wrong with this data set. Okay, at least this quantity column. That is what is clearly explained here, right? That means there is a wide spread of the data, indicating that there are outliers. Okay, so how to identify is at the 75th percentile, if you see, At the 25th percentile, it is 1 quantity. At 50th percentile, which is the median, which is 3. Now you can see the problem, which is at the 75th percentile, which is 10. There's a drastic difference between the 50th percentile and the 75th percentile. This indicates that there are outliers. This is why you do this describe function to identify where the outliers are basically existing in the data set. That is the magic of using this quartiles. So at the first quartile, second quartile, there is no issues. But at the third quartile, there is a drastic difference between uh, you know what is happening in the data set. So this basically indicates that there is outliers at the 75th percentile. Okay, or you can say third quartile. Now let us come to the unit price. Okay. Now in the unit price, we have got some analysis, for example, like mean value. And even if you see here, the standard deviation is very high also when it comes to the unit price. So you can see the average is approximately 4.61, correct? No, 4.611114. So it's around 4.6, correct? No? Then the unit price again shows from minus to plus, and that here, if you see, this suggests the presence of errors or noise in the data, as negative prices don't make sense. Correct, no? We see here in the quantity, it might be the negative indicates that the product is returned. So since since the product is returned, that happens when it comes to online transactional data. But when you see the unit price, okay, why we'll have a negative unit price? That is why I've mentioned it doesn't make sense. Now, in the similar quantity, if you see what is happening here, there is a difference, right? At see where is the minimum? Minimum, and see the maximum value. And here you can see at the 25th percentile and 50th percentile, very similar. And there's a lot of difference between, okay, not like this much of difference. Okay, this is very huge. 3 to 10 is huge for one, and the difference is basically 2 here, or maybe 3 you can expect when it comes to here, or 2 to 3. So maximum you can expect up to 6, but there's a huge difference. Here it's not that much when it comes to not as much as quantity, but there is a difference. I would say this is a rather alarming thing as well. Now, in the unit price, you can see that there is a significant presence of outliers. That is what I wanted to tell at the 75th percentile. Okay. Now, let us come to the customer ID part. Now, customer ID part, okay, usually mean and all doesn't make sense, right? But you can identify that there are some missing values in the customer ID that also we have actually identified because there are only these many entries. Out of 5.4 lakh, only 4 lakh entries have been made. Okay. So next, coming to the invoice number and the stock code and description. The invoice number is basically they are separate invoice numbers. Okay. The most frequent invoice number, okay, is this one, which is repeating these many times. Possibly there is a larger transaction made with multiple items that we have to analyze and see. Okay, that is why I mentioned the word possibly. Okay, next is the stock, and there are 4070 unique stock items you can see, right? You can see a unique of 4070. What this tells you is the most frequent stock is this particular ID appearing these many times in the data set. Okay, so next is the description part. If you see, there is a unique of 4223 when it comes to the description part. Here, when you see this 4223, there are 4223 unique products in the data set. And the most frequent product which is appearing 2000 times, right? You can see here 2369 times is this white hanging heart tea light holder, which has been repeated, 2369 times. If I'm, yeah, 2369 times, right? And in the description part also, there are a lot of missing values as well. Okay, not as much as uh, this customer ID, but there is a description. There is a missing value in the description part as well. Okay. Now let us go to the next part. So there are different countries. Okay. The transactions are coming from 38 different countries. So you can see here. So unique is the UK. Sorry, unique is 38 countries, and most frequent uh, is happened in UK. So which has been repeated 4.9 lakh times, or most transactions are done in the UK because it's basically a UK data set. Okay. This is the initial thing. Now, let us do some further analysis by calculating the missing values. So this part will calculate the percentage, a formula to identify the number of missing values in the data set. And how many values are there, right? What is the percentage that we can calculate? And now the next part actually tells you how much of, by creating a bar chart. Okay. So here I'm creating a bar horizontal chart. Okay. So maybe I'll mention like this. Okay. I'm creating a bar horizontal chart, right? So where it will create a horizontal chart with this particular size. Now, what exactly I'm trying to do here is I wanted to see how much percentage of, because there are two columns which there is a missing value, right? The column is customer ID and the description. So if you see the description column, there is only 0.27 percentage of missing values, right? So basically with the industry benchmark of at least 5%, you can remove, at least 95% of the data should be there, but 5% can be considered and deleted. Okay. So considering that, not even 0.5 percentage of description is there, right? So fine. But the problem is particularly in the customer ID. Customer ID, if you see, there is around 25 percentage. That is very huge. That means 1/4 of the customer IDs are missing. So this is not acceptable, right? It's a huge data loss which has happened in the customer ID column. Now, if I scroll down, my analysis is basically on that. So nearly a quarter of missing data. So it is very important to cluster the customers and create a recommendation system. So what will happen what will happen because of this is it creates a lot of, biasness and noise in the data. So, insignificant things. So moreover, this, since the clustering is based on customer behavior, that is what basically on the behavior of the customers, we are going to classify into, or, group them into clusters. It's crucial that we have an accurate data and customer identifiers. So therefore, removing the rows with missing customer ID seems to be more reasonable approach to maintain the integrity of the clusters and the analysis. So what happens is it is very difficult to group the customers without their customer ID. So even though it is a huge amount of data, we actually have to remove it in order to maintain, at least we try to get more analysis from that 75 percentage of the customers what are existing into our existing the data set, which is who has whom we have been provided with perfect data, right? Nothing is missing, right? Everything is intact for that 75% of the customers. So next part is the description part. So in the description, we have a very minor percentage, right? So now here we can actually notice that there are inconsistencies also in the stock code, right? But it is fine. Okay, I would say it is fine. So whatever is and 0.27 is a very small number. So I would basically recommend to delete the wherever the missing values are basically there. So this customer ID is a biggest problem. Actually, we don't delete 25% of the data. That doesn't happen actually. But to avoid that biasness being creeped into the data set, or occurs into the data set, we have to delete that things. Okay. Now let us okay, just have a look that where our null values are actually there. Okay. Now wherever we are finding that particular null values in the column of customer ID and description, right? We are going to drop those particular rows. Okay, fine. Now, what I'm trying to identify next is I'm trying to identify the duplicates. Okay, so the next part is basically identifying the duplicates in the columns like invoice number, stock code, description, customer ID, and the quantity. Okay, and I'm sorting them, okay, from the unit price, or maybe you can use some other quantity. Yeah, I can sort it by the values. Yeah, here I've done sorted by the the quantity what I have, right. So here by quantity it has segregated. Okay, so you can keep, right, you can segregate by a particular by a particular attribute. So now, if you see the next part, what has happened? This is a very important strategy what I wanted to apply. So in the context of this particular project, the presence of completely identical rows include identical transaction times. This suggests that these might be data recording errors rather than genuine repeated mistakes. So keeping these duplicates rows can introduce noise and potential inaccuracies in the clustering and the recommendation systems. So therefore, I'm going to remove this identical duplicates from the data set. Okay. So removing these particular rows will help in achieving a cleaner data. So first, what we have done, we have removed that 25% in the customer ID, right? Where which helps in occurrence of more bias, right, in the data set. Then we have or having we are working with the duplicates where which will not help us in handling the data in a smoother way. So what we are going to do is we are going to remove these rows with the help, you know, and what happens if you remove this is actually which will in turn would aid in building more accurate customer clusters based on their unique purchasing behaviors. So moreover, it would help in creating a more precise recommendation system by correctly identifying the products within the most purchases. Okay. So to identify or strategize, to correctly identify. So to correctly identify, that which actually which customers has which kind of purchasing behavior, we have to handle these duplicates and delete them. Now the next step is deleting that particular deleting those particular duplicates where how many particular number of, that is what we are printing a statement. So basically around 5,000 entries in the data are deleted because they are duplicates. Okay, so it might be a data entry error. Now, if you see carefully, now we have the shape around 4 lakh. So a lot of things have been deleted, right? Now, let us start dealing with the status of the invoice starting with C. So what is this basically C is about? It is the cancelled invoice. That means the transactions might be cancelled. Okay, so let us process now with the next important thing is processing with the transactions which are cancelled. Okay, so now let us see the cancelled status. Let us try to calculate, try and identify the quantity and unit price. Okay, so let us not calculate for the customer ID. Okay, only let us calculate for the unit quantity and unit price. Okay, so you can see here there are around, which are cancelled. So it is around some, 8,872 transactions which are like that. Now let us see the inference on this. Okay, so if you see the inference of the cancelled transactions, all the quantities in the cancelled transactions are negative, indicating that these transactions particularly are cancelled. So the unit price column has a considerate spread showing that a variety of products from low to high were a part of the cancelled transactions, right? Now, let us implement a strategy now to what should we do with this cancelled transactions? What is our next approach, right? So usually the next step is basically, right, you would have predicted. We obviously will calculate the percentage of, the 17th line, you can see that. So you can see that the percentage of the cancelled transactions. So here, if you see the cancelled transactions, they are around some 2.2% in the data set. Now, what is our strategy going ahead with this cancelled transactions is, so if we consider the project's objective, that, why we started this project, the agenda of this project is to, calculate or, cluster, I can say, or put a certain people into a certain group. So we have to identify a certain clusters based on the purchasing behavior, the preferences, and in the end, eventually create a recommendation system. That is what we are going in the direction of trying to do. So it is imperative, or it's very imperative, to understand the cancellation patterns of the customers. So therefore, the strategy is to retain these cancelled transactions in the data set, marking them distinctly to facilitate further analysis. So how do we do this? We have decided not to drop. Okay, fine. So what we are going to do then, that is what the next step is going to be. Enhancing the clustering process by incorporating patterns and trends observed in the cancelling data, which might represent certain customer behaviors. Okay, so if a particular customer is actually behaving in such a way that he's canceling the transactions, so what does it tell you? What it is telling you? What we can do, right? If these kinds of customers you're seeing, allowing the recommendation system to possibly prevent suggested that, like, to have a high likelihood of being cancelled, thereby improving the quality of the recommendations. So for example, what is the best we can do is we can identify that what is the reasons or why only these particular transactions have been cancelled. So that analysis can be done. That is why let us strategize and let us visualize and understand also. So this is what we feel I felt when I'm doing this. So now let us go a little forward. Okay. So now let us see the unique stocks. How many are there? So I think unique stocks you have identified in the stock code as around 3684 that we have seen in the describe function as well. Now, this 18th step is fine. I think you would have understood very easily. Fine. But now let us go to a little more analysis in this 19th step. So 19th step, what exactly we are trying to do is the important thing what is we are trying to focus is to understand the top 10 most frequently approached stock codes. So what is the stock code which is being approached more number of times? Okay, that means that many amount of times that particular product has been purchased. So here, if we visualize, we can see that you have 0.5 percentage of this particular product, which is the stock code, which has been right. So you will see a very small percentage because there are a lot of products in the data set. So if you see the top 10, the difference between the first one and the last one, the percentage is very small. See, it starts with 0.5 percentage, 0.51, I should say also, because the difference is very small. And the 10th item, the you know the percentage is 0.28. So see the difference. It's only 0.23 difference between 10 places. So 5147, 41, 35, 35, 34, 30, 30, 28, 28. And even you have the positions also, you have the same percentages. So such a small percentage difference is there between the products which is most frequently bought. Okay. So next, let us infer or let us create an inference on this. So we already know that there are around some 3684 unique stock codes, correct? So this, what does this indicate? So this basically indicates there is a lot of variety of products, right? There is a lot of variety in the products available on the online retail store, right? So this diversity can potentially lead to the identification of distinct customers with preference for different types of their products. Now, we have built the top 10, right? And we have that particular codes, okay, which actually tells you which kind of product it is. We can just map it and we can check it. Okay. So let us further also investigate to understand any anomalies and all, right? Because very important thing is to build a recommendation system for the products what we actually have, right? So let us further investigate because a lot of further investigation is very much required when we actually do a particular project. Okay. Now let us move little forward. Now, if you see that in that particular stock codes, right, what is the value count? Okay. So there is, if you see the particular count of value, right, in that particular stock codes, right? So this particular number 5 is occurring, 3676 times. Okay. And this 0 is occurring 7 times and this 1 is occurring 1 time. So this is a unique identification of that particular stock codes. Now, what does this tell you? What is this 3676? What is this 7? What is this 1 exactly? How does, how I will understand or what is it is telling actually? So here you can see that 3676 is a huge number. So totally we have 3684. In that 37 exactly 5 numerical characters, right? Because you can see that a particular stock code is having either 5 or 1. But what is this 0? It is out of the blue, right? So what is this? How a stock code will contain 0? So let us see. Now that means most of the I can say most of the uh, stock codes are are having 5 characters, right? And there are there are a few which is like 7. So you can see that these are basically anomalies or errors in the data, very abrupt or unusual observations in the data set. So definitely you can identify that these 7 are anomalies, or you can say outliers. Major outliers in the data set, basically you can classify them as anomalies. So now, and what about this one, right? There is one numerical character, right, which is basically classified as one character, right? So these are clearly deviating from the standard format of what we are trying to use. So let us think logically. Stock code is having usually 5 digits or 5 characters. So if you see something like something like a 0 characters or 1 character, you can identify that it might be an entry mistake or a typo error, or it is not uh, entered correctly, or it is not a genuine stock code. So these are basically the outliers. So now what we are going to do is we are going to remove which is having 0 and 1. Okay. So the next stock code, what we are trying to do is there are a certain kind of uh, you know anomalies which we are going to delete now. Okay. So the next code is basically deleting those anomalies which is having 0 numerical characters or 1 numerical characters. Okay. So that is the next thing. Now let us go to the next part. Okay. So if you see that out of that 3684 characteristics or characters, what we have, or you can say stock codes, if you calculate the percentage, right? So it is coming around some 0.48 percentage. So if you see that there is 0.48 percentage, what it tells you, these are the percentage of anomalies, and you can expect anomalies to be around some 0.1% or 0.51%, something like that on total, right? So you can actually delete these transactions. So because these are basically the or the stock codes, which are basically are the anomalies. Now, these are basically something which is representing something in this data set. So if I just have a look at the data set also, it is showing that these are some of the charges. For example, like the bank charges, maybe some post charges, like postable fees, something like that. So, and these also, the percentage is also very small, and it doesn't impact very much if we delete this particular percentage of stock codes from, because it is hardly around 1%. It's just 0.5 percentage, around 0.5. So hardly it is, hardly it will impact, right? So we are going to delete this particular uh, percentage of postal codes, sorry, or the stock codes from our data set, right? So that is what the next strategy is. So we are going to delete that. So now our shape of the data is basically around some 4 lakh. Okay, so now let us actually plot now, right? The next important thing is plotting the first or I can say top 30, right? More frequently purchased descriptions. Okay, so here you can see, if you plot, you get a graph, right? The most occurred is this white hanging heart light, tea light holder, right? So this is one of the products you can see that has been purchased more highly, or which has been repeated in the description. Okay, right. So let us go down a little. So here, yeah, you can just infer very easily. Okay, so this is mostly the most frequent descriptions are generally the household items, particularly those associated with the kitchenware, lunch bags, and decorative items. So interestingly, all the descriptions are in uppercase, which means to be standardized in the format. So see the description, correct? No, it's all in the uppercase, right? So what we are going to do is we are going to standardize, right? Create first letter. Okay. Now we'll change that. Okay. Now let us see what inference we can give that. Now, so however, sorry, interestingly, all the descriptions are in uppercase. So we apply the standardizing format for entering the product descriptions in the database. So, however, considering the inconsistencies and anomalies encountered in the dataset so far, it would be prudent to check if the descriptions entered in lowercase or a mix of case styles. That means first letter capital and then small. So we'll try to identify that as well. So now let us see if anything contains any lowercase, right? So if you see carefully, it is lowercase is exactly there in some of the things like this grams, like this centimeters, right? Here I can see pack 1/2. So it is not exactly with the name it is there. So upon reviewing, that is what my next review basically is about. So upon reviewing the descriptions that contain the lower characters, it is evident that some of the entries are not product descriptions, right? So that is why it is fine now to go ahead and strategize in such a way to change the, uppercase, right? And completely, let us change that capital form. Okay. So now, here we are describing the characters, right? So service related like the next day carriage and high resolution images. They're not actual products. Okay, so we cannot build recommendations for these systems. So now, leaving these two out of the thing, apart from this, we are trying to convert, right? The first letter is capital and the others are small. So this is what the basically code is about to convert them as well. So now let us go to the next part, and the shape of the data is almost same as what we had before. We'll just pull it up. Here, leaving those two, we are identifying the other part. So there's a light difference in the shape of the data. Okay, not much, but very light. Okay. So next, let us go to the unit price. Okay. Let us describe, because when we have done before, it was different. Now it is different because we had a lot of changes in the data set. So a lot of anomalies, missing values, a lot of things we have dropped in the data, right? So now what happens with this unit price? Let us see. So now if you see that there are the outliers are not that here. See the, minimum unit price, right? I'll come to that minimum zero, okay, that I've given in my inference. But here you can see in the 25th percentile to 75th percentile, they are very near to each other. That means it shows that there are not much outliers in the data, right? Now, but there is a problem here. This column is a unit price. And I am worried about seeing this zero as a unit price. How can a particular product have a zero unit price? Correct, no? It should be at least $1 or a $0.5. Some price, okay? Let us not say, just don't, let us not put any vague price, but let us say some price it should be. That is what concerns me. That is what my next inference is going to be. That means the unit price value zero suggests that some transactions where the unit price is zero, which is then very unrealistic. So potentially it is indicating that it's a free item. So for example, if you sell products online, will you give products for free? No, right? It's a simple no for an answer. Or it might be the second problem. What it is? Data entry error. So now let us understand the nature of that particular data. So it is very essential for us to investigate these zero unit price transactions going further into the data set. So this detailed analysis of the product descriptions associated with the zero unit prices will be conducted to determine if they adhere to the specific pattern. Now, let us identify that how many are there like that. The 30th line of the code is that. So it is identifying wherever the unit price is zero. Okay. So it is identifying some of the things. And I've got a count which is 33 transactions. Here you can see. So where the product price is basically zero. So these transactions have a large variability in the quantity of the items involved. So ranging from 1 to 12,540, which is a substantial standard deviation because that is the maximum value we got. And even if you see the standard deviation, it is around some 2176. And see the mean value, and mean and standard deviation are very far from each other, which is very concerning when you see this 33 transactions which are having zero price. So including these transactions in the clustering analysis might introduce noise because just by looking we can understand the mean and standard deviation are there's a huge difference, and there's again a huge difference between the 25th percentile to the 50th percentile. Okay, somewhat better if we accept also, but from 50th to 75 there's a lot of difference, and see the maximum value. So I would not even recommend to include any of these into the analysis part. So next thing what I'll do is I try to remove them. Okay. I feel that these are some of the data entry errors which are actually produced. Okay. So here my inference is that on that. So my strategy is going to be there is a small number of these transactions. So I think around some 3.9 lakh, so almost 4 lakh data. 33 is a very small number. So if you see that there is a very small number which are the potential errors in the transaction, the strategy would be to remove them. That will be a better option rather than keeping them and creating a small uh, you know problem in our analysis, right? Better not to do that. So this would recommend in maintaining a cleaner and more consistent data set, which is essential for building an accurate, reliable clustering model and the recommendation system. Okay, so next thing is now removing the records which are having the price which is greater than, so keeping them which is greater than zero and removing those records which are less than zero. Okay. Now, let us just try to understand that what is the focus, what we have done here. Okay, then we'll stop session here. Okay, so we'll continue the project tomorrow. The first thing we are going to do this project, and then we'll go to the next concept. So this is very important to understand because k-means here, it's not just about the clustering. It is also about building a recommendation system. So this is a common thing which happens in the real world projects. So I've given an understanding on that also. So now in the k-means clustering, the algorithm is both sensitive to the data as well as presence of the outliers. So all the process, what we have done is what a process of data cleaning and preparing the data for applying the clustering algorithms. So we need a neat and a clean data when we want to apply these algorithms. So what happens is as they significantly influence the positions of the centroids, potentially leading to the incorrect clusters. So it is going to change the average value because the centroids also will change. So which will in turn create an inappropriate or incorrect clusters. So that is why keeping this in mind for the context, the project where the final goal is to understand the customer behavior, correct no? And preferences through the k-means clustering. So it would be more prudent to address the issues of the outliers after this feature engineering phase, where we create a customer-centric data set. So what we need is the correct data to analyze our data set. At this stage, the data is transactional, and removing outliers might eliminate valuable information that play a very crucial role in segmenting the customers later on. Okay, so that is why we postpone the outlier treatment and proceed to the next stage for now. So let me stop here. Okay. So once we'll continue from here in the tomorrow session. Okay. So it's a very big project actually. Okay. So this is why I've taken up this particular project. I will tell you. This is actually very close to what we do in the real world scenario or a real corporate environment when it comes to the online retails or any retail business, right? So segmenting the customers. So this is what actually we do. Okay. So taking a very small data set and applying a clustering method, I felt it's not in an very appropriate because we need to understand what exactly happens in the real world scenario. So that is why I've taken this particular project in making to understand that how the data starts, and even before applying the clustering method, how much we need to clean the data first, and how data cleaning is very important when it comes to the real world process, and how do we use this EDA process, and how do we apply the feature engineering process, right? How do we clean, how do we prepare it, how do we transform? That is very important when we are actually proceeding with the clustering methods. So this is here I will stop. Okay. So if you have any doubts, you can ask me. I think some 2 minutes is there. So 2 3 minutes. If you have any doubts, you can ask me. Then or else we can wind up the session. So yeah. So again, and to again, the project I'll continue tomorrow. Okay. So I think till 31st line we have done. There's a lot. Okay. A lot of things need to be discussed. Then we have to go with the applying of right the k-means clustering and then the recommendation systems. Right. So this is what we are going to do in the tomorrow's session first. Okay. After that, we will go with the next concept. Let me check for any questions. Ma'am, you can we can just wind it up, I guess. I can't see any questions. Maybe if they
Yeah,
have
sure.
tomorrow, also they can ask me anyway, because we'll be continuing this project tomorrow. Yeah.
Yeah, yeah. So, yeah. So, students, yeah, we are done for the day. We are winding up. And one more important update from tomorrow, the session will be at 7 p.m. I am sorry, 7:30. So it starts from 7:30 and ends at 9 p.m. only. So, but we are starting like half an hour late. We are starting at 7:30. Okay. So, if your friends are not there in the session, they already left. If they already left, kindly inform to them that from tomorrow we are taking from 7:30. Okay. I hope you all understood. So from 7:30 to 9 o'clock, we are going to take a session from tomorrow. Okay. Yeah. So I'm sharing the attendance link once again on the chat. Kindly mark your attendance and then you can drop the session. Yes, Shashank sir, thank you so much. We'll again meet by tomorrow at 7:30.
Okay, ma'am.
Yeah, thank you, sir.